This is the second in a series of resources that considers the four different types of sequences. Part 1 defines sequences and also considers sequences defined by a general rule. Part 2 inspects arithmetic sequences, the general idea, how to find specific terms in the sequence, and how to find a partial sum of the sequence. Part 3 looks at geometric sequences, the general idea, how to find specific terms in the sequence, how to find a partial sum of the sequence, and also how to find the finite sum of an infinite series. Part 4 considers recursive sequences. We will look at the basic rules and formulas, then work through examples of each. In the previous resource in this series, we discussed the general sequence, where each term is defined by a function with the element number as the input. Other types of sequences follow special patterns. One such is an arithmetic sequence. Here, each number in the sequence differs from the previous by a constant amount. In other words, to get the next term in the sequence, we add the same amount each time. This amount that we add is called the common difference. Labeled as D, we can easily find the common difference by subtracting the second term of the sequence minus the first term. The general notation for an arithmetic sequence is that a sub n equals a sub n minus 1, the previous term, plus d, the common difference. Suppose we want to find the first four terms of the arithmetic sequence whose first term is 100 with a common difference of negative 30. Since we are told it, the first term is 100. To find the next term, a sub 2, we need to add a sub 1 plus the common difference. We have 100 plus negative 30, so a sub 2 is 70. Finding a sub 3, we add the common difference to the previous term. This is 70 plus negative 30, which leaves a sub 3 equal to 40. A sub 4 will be 40 plus negative 30, which is 10. Finding the first few terms of an arithmetic sequence, we can just keep adding. But what if we need to find the 50th term in the sequence? We don't want to find all 49 previous terms. Luckily, there is a nice formula to find any term in an arithmetic sequence. A sub n, the nth term in the arithmetic sequence, equals a sub 1, the first term in the sequence, plus the quantity n minus 1 multiplied by the common difference d. Where does the n minus 1 come from? Recall that we don't actually start adding in the common difference until the second term in the sequence. So any term will have n minus 1 copies of the common difference added in. For example, suppose we want to find the 19th term of the arithmetic sequence that starts with 29 and has a common difference of 5. Let's just use the formula. We plug in the pertinent information that we want a sub 19, which equals 29 plus the quantity 19 minus 1 multiplied by 5. Subtracting inside the parentheses, we have a sub 19 equals 29 plus 18 multiplied by 5. Multiplying, we have a sub 19 equals 29 plus 90. Combining, we find that a sub 19 equals 119. Another task we sometimes are required to complete is finding a total for a sequence. or at least some finite portion of the sequence. To find this partial sum, we could list out all the terms, then add them up. As with the general term, there is a formula to find these partial sums. The sum of the first n terms of an arithmetic sequence equals n multiplied by the quantity a sub 1 plus a sub n divided by 2. In other words, we average the first and nth terms, then multiply by n. This means we will have to find the nth term before we can find the total. Suppose we want to find the sum of the first 15 terms of the sequence 3, 7, 11, etc. First, we need to find the common difference. To do so, we subtract the second term minus the first. We have 7 minus 3, so the common difference is 4. Next, we will use the formula for a general term to find the 15th term. Plugging in, we have a sub 15 equal to 3 plus the quantity 15 minus 1 multiplied by 4. Subtracting, a sub 15 equals 3 plus 14 multiplied by 4. Multiplying, a sub 15 equals 3 plus 56. So a sub 15 equals 59. Now we have everything we need to find the partial sum. Plugging into the formula, we have the sum of the first 15 terms equal to 15 multiplied by the quantity 3 plus 59 divided by 2. Adding leaves us a sub 15 equal to 15 multiplied by 62 divided by 2. Dividing, s sub 15 equals 15 multiplied by 31. So the sum of the first 15 terms of the arithmetic sequence is 465.